Welcome everyone. So far we tested one sample, and in this business scenario we are going to test two dependent samples, and we are going to use the same example we use in the confidence interval. We want to test the efficiency of a new medicine for blood pressure. We need to find if mu A is less than mu B. Mu A means the average blood pressure for the population after taking the medicine, and mu B is the average population blood pressure before taking the medication. So in other words, we want to see if the blood pressure is decreased after the sample of patients took the medicine. Mu A less than mu B, that means we want to find if that medicine is already reduced the blood pressure. And we can put our hypothesis in a different form. D, which is the difference less than 0. So based on that, mu A will be minus mu B, and the right side will have only 0. So that's how we got D less than 0. And the null hypothesis is the opposite. It's D greater or equal 0. We have 15 observations about 15 patients. In examination 1, we took the blood pressure for these 15 patients before taking the medicine. And after that, in examination 2, we took the blood pressure after taking the medicine. And here is the difference. And because we have only 15 observations, which is less than 30, we need to use t-distribution test. And the formula is very similar to the z-test. Except here we don't have sigma or the population standard deviation, we are using sample standard deviation. And we already got these numbers from the previous tutorials. So we just need to plug in the values. X bar, the sample mean, which is minus 5, minus mu 0, which is the difference here, equals 0, so minus 0, divided by the standard error, which is 3.31. And the result here equal minus 1.51. And as we said, it is easier to take the absolute value for the t-score that we found, which is 1.51. And because this is a medical test, we need to be as precise as possible. So that's why we need to test it in 99 confidence level. So based on that, alpha is 0.01 or 1%. And the degree of freedom is n minus 1 equal 14. So let's find the value when the degree of freedom is 14 and alpha is 1%. So the degree of freedom here is 14 and alpha is 1%. So the value that we need is 2.624. Let's go back and see if we can accept or reject the null hypothesis. The absolute value of t is 1.51, so it is located here. It is smaller than 2.624. In other words, we don't reject null hypothesis, so we accept it. That means we reject the alternative hypothesis. In other words, we can say the medicine is not efficient to reduce the blood pressure because we don't have a significant evidence that the difference D is less than 0. So let's this time use the online calculator to find the p-value instead of using the t-value from the table. The absolute value for the t-score is 1.51 and the degree of freedom is 14. The significance level here is 1% and we have only one-tailed, so we'll keep it one-tailed. Click on calculate, scroll down, and you can see here the same results. The p-value is 0.7664, which is greater than 1%. So that means we cannot accept the alternative, we accept the null. In other words, we don't have an evidence that the medicine is efficient.